This video is an understanding of bitwise operations on vectors OR and the XOR. In the previous video, we spoke about and we also explained the binary numbers in addition to explaining the and. So please refer to that if you needed more clarifications, but let's start looking at the OR. Now the result is a new binary number where each bit is set to 1 if at least one of the corresponding bits in the input numbers is 1, otherwise it is 0. So any 1 is going to be equal to 1. So let's have a look at how that works. I'm going to call the method display vector, and we're going to be passing in two variables. So let's just have a look at this method really quick for those who haven't seen it. So it's expecting two arguments. One is the operation name and the other one is a vector. And it's basically just printed out. So the operation name in this case is going to be just a string. So I'm going to call this bitwise OR. And we'll be passing in a vector, and that's going to be the bitwise operation OR. So vector 1 OR, that's the pipe. It's on top of the shift on my keyboard. I'm not sure if you've got the same, but sorry, on top of the enter key on the keyboard. So just press shift at the same time so that you can get the same symbol. Okay, so let's see what this prints for us. So each result is stored into a new vector. This whole thing is actually a vector, and that's what we have. So what's happening? Let's have a look at the explanation in this comment. So these are the original vectors. Basically, I've just copied these into a comment. And we want to look at, say, for example, we'll be looking at 1 or 8. 1 or 8 gives us the decimal 9 because any 1 is going to be equal to 1. So if it finds any 1, so 1 or 0 is equal to 1. 0, 0 is 0. 0 or 1 here is 1. So that's equivalent to 8 plus 1. So that's actually 9. And that's why we get this value here. Next is going to look at 2 or 7. And every value is then stored in the new vector. That's the result of this operation. So 2 or 7 pretty much gives us 1, 1, 1, which is equal to 7, because that's 4 plus 2 plus 1. And then 3 so that's 7. 3 or 6 also gives us 1, 1, 1, which is equal to 7. That's 7. 4 or 5 gives us 101, which is equal to the decimal 5. So that's why we have that one. So that's 4 or 5, and 5 or 4 is pretty much the same. Also gives us 5. And then we have 6 or 3, that gives us 111, which is equal to 7. 7 or 2 gives us 1, 1, 1, this value here, which is also equal to 7, given this 7. And then we have 8 or 1 gives us 101, so 1001 basically, which is equal to 9, which is why we get this 9 here. So that's the operation result of OR. Now let's have a look at the XOR. I'm just going to copy this line and paste it here. For the XOR, you just want to use the symbol Shift 6 on the keyboard, and I'll change this one to X. So this is the result that we get with XOR. That's because the result is a new binary number where each bit is set to 1 if exactly one of the corresponding bits in the input numbers is 1. So if there's only 1, but not 2 1s, so if they are the same, it's always 0. So 0 and 0 gives us 0, 1 and 1 gives us 0, but 0 or 1, 1 or 0 gives us 1. So to explain this result, we want to look at 1 XOR 8, 1 XOR 8. So any different numbers. So if we have a 1 with 0, that gives us a 1. Then we have another 0 and 1 here. So that's 1001, which is equal to 9 because that's 8 plus 1. And then 2 XOR 7 gives us 101, because if there's similar numbers, then it's set to 0. But they're different, it gives us 1. So that's equal to 5. That explains the 5 here we get. Then 3 XOR 6 gives us 101 because it kind of zeroes out the common numbers, which is the common two ones, which is equal to 5 in decimal. 4 XOR 5 is equal to 1 only, because it sees two similar ones here, or 1 and 1 is equal to 0, which is pretty much equal to 1 because it only takes out that first value here. The same for 5 XOR 4, same thing. And then 6 XOR 3 gives us 101 because it zeroes out these two. So we have 1 and 1, which gives us 0, and that's equal to 5 in decimal. Explains the 5 here. The next 5 comes from 7 XOR 2, which is also 101. And the last one gives us 9 because it's got that one and the one from the beginning, so that's equal to 9 in decimal. So the output is a new vector, which pretty much is this one here. So that is an explanation of the OR and XOR bitwise operations on vectors. I hope it was useful, and I'll see you in the next one.